I use the word twice elasticity, your demand is percentage change in quantity demanded divided by percentage change. So this is not an easy chapter because, like I say, because it's so analytical and you have to apply equation to it. I tried to go a little bit slow. So basically what it is, this is a cause, and this is the effect. So in other words, if you raise the price, like the example we gave, right? If you raise the price of the good, so according to law of demand, then you would naturally demand less units of it. And then, of course, there's also an equation there. And again, I have mentioned to you, if one of you remember and mention it to me during the next test, I will give this equation to you. I don't do that very often. This is probably the last one I give. So this will be changing Q divided by Q naught, which is original Q. So you see, take note during the class help because, then when you're writing, you're thinking a little bit there. And this is your Q1 minus Q naught, and that would be your Q1 minus Q naught. We gave example, the original price versus the new price before and after the change, and so is a quantity before and after. So at the end, you will have something like, let's see, P naught, Q naught, and then we gave example, remember? So this would be your changing, I think it's changing PQ. It's basically your P naught, Q naught, 1 over slope. Okay, so again, once again, this is a review. We already covered that. Myers, were you here in last class? Were you in my last class?
No.
Okay, you weren't here, right?
Right.
Okay, I thought so. Thank you. So, we got this right here, and this is your P and Q, and this is your slope down here. And so therefore your slope will be change in P divided by change in Q. Okay? And your 1 over slope will be change in P divided by change in P. So that's right here. So, and we have name for it. Let's see if you remember. If you took notes the other day, you will be able to tell me. This is an easier calculation. We have a name for this. What is it?
Price.
Point price elasticity of demand. And this is a little bit more elaborate because you need two P's, two sets of P's, two sets of Q, and we call this calculation ARC, price elasticity of demand. Now, because we gave two types of example in the class the other day, I do want to make sure that you know the distinction between the two. Our textbook does not come out and say that, but knowing the difference helps. Because when you only have point, right, we're only talking about point, we use the second half point. But if we have arc, two sets of prices, two sets of quantity, then we use the other one called arc price elasticity of demand. Okay, I just remember what I wanted to say. So if you're absent, do not ask your classmate to sign on your behalf. I would really appreciate it because I typically know all my students by now, by name, by face. So if you're not here, I think I'm away, and please, nobody sign on behalf of people who are not here. Because, that's not good. And of course I know. Okay, so right here, there are two extremes to that. That is, remember the other day we also covered this. Okay, there are two, we talk in terms of the steep, how steep the steepness of the two demand curve. And we say this one, D1, is steeper than D2, correct? Right. So therefore we say D1 is less elastic. We use the term less elastic or inelastic. Same thing. And then for D2, we describe it as more elastic. So don't get the two confused here. Because we gave the definition that if it is greater than 1, it's considered elastic. If it is less than 1, we consider it inelastic. I'm going over the concept. This is like a review. So right here is unit elastic. Now we do have extreme case. Extreme case would be, remember the other day I mentioned too that as we move, look at that tennis ball right there. That's the midpoint. Everybody notice that? So if this is like, say, 20, what would this be?
10.
That would be 10. And if this is 10, what would this be? That would be 5. Okay, so you got 5 and 10 here. That's a midpoint. And that's where your price elasticity or demand for that particular good is unit elastic. And you also notice that as you move down here, slowly down this way, thank you, it gets more and more inelastic. Or another way to say is less and less elastic. Says the same thing. But if you move up this way towards that A there, it gets more and more bigger, more and more elastic. So what does that tell you? Along the same demand curve that you have different elasticity on different point of the demand curve. Although the slope is the same, right? Because we're looking at the same graph. So that this number, as we gave the example the other day, this will be the same slope here. But this number will be different, P naught and Q naught. So of course, if you only have one point, right, you don't have two sets of prices, two sets of quantity, then your P naught will be just the price that you're looking at, or the quantity that you're looking at, okay? So now, sometimes you get this. What is this? The red line, it's horizontal, right? And this is your demand curve, so we call this perfectly elastic demand curve. So this is the extreme of the most elastic demand curve. What does that mean? So that means that your price elasticity or demand is considered infinite. Even the slightest change in price leads consumer to find substitute. Because, so in this case would be like the car, SUV, we're talking about. Big ticket item. So that, it would be very elastic because you have a lot of substitutes. So if you try to raise the price, people will find substitute. Yes, questions? Do you have a question?
Yeah, I was wondering if anything in reality is perfectly elastic.
So that's what I just said, the car, big ticket item, like Bahamas vacation. So anytime the price goes up, home would be a good example, like house, buying a home, because that costs about $200,000. Does anybody here has $200,000 to buy a home right now? Usually we have to take out loans from the bank, right? I don't have, do you? No, okay, I thought so. So then if you try to raise the price a little bit, say by 10%, I mean, that's a lot. 10% of 200,000 is what? 20,000. So then you say, never mind, we'll find other substitutes, maybe a mobile home or something. Okay, so the other extreme, perfectly inelastic, it stands up like a lamppost. It's vertical. So this is a case where we apply the examples are important. This is the case that we say price elasticity or demand actually goes to 0 instead of going to infinity. Does everybody was familiar with that sign I used, right? Infinity. And basically it means you definitely you will substitute. So now, if you have a case like that, we say, price elasticity, the demand is 0. Consumer do not switch to substitute even when price increases dramatically. Now, this will apply to goods that are very essential, very important, necessity. For example, water. I mean, we cannot live without water. What do you use water for, other than drinking?
Bathing.
Right, take shower, and what else? You water your plants, you wash your dogs, your pets with it. So now let's just say that the price of water has gone up by 10%. Would any one of you actually will cut down your shower time from 40 minutes to 20 minutes? Would you just kind of like stop the plants and not wash your animals, your pet? Probably not. You probably just go as business as usual, consume as you have been doing, and because it's considered a necessity. Now, another extreme would be like, how many of you know people who have diabetics? Who are diabetics? Okay, and you know that they have to take the insulin injection. So prescription drugs are a necessity. That is, no matter how much the price goes up, whether it's water or whether it's prescription drugs, as example, can't say that, example of necessity. So you will still consume the X amount, the fixed amount. Insulin, yeah, you have to do your injection. If the price goes up, you're at the mercy of that price increase. You still have to consume that fixed amount. So everybody get it? So that's what your perfectly inelastic means. And remember, we're applying it to demand curve, not supply curve. So the next chapter we will actually talk about price elasticity of supply. They're a little bit different and not as straightforward like, oh yeah, this is demand curve, flip side of it is supply. Well, that is true, but a little bit more. So next we want to give about 4 examples of what happens if the price elasticity goes up. What happens if the price changes? How does it affect your total expenditure? Now let me see if anybody here remember what is the definition for total expenditure. Anybody remember the other day we talked about it? Tell me what it is. Look back in your note.
Price times quantity.
Okay, very good. Thank you, Mr. Parker. E times Q. Very good. Everybody got that? So we have 2 cases here. The first case, we want to look at a case of inelastic demand. Okay, that's case 1. Then case 2, we'll look at elastic demand. But first, look at the inelastic demand case. So we have an example up here for movie ticket. So this is a demand for movie tickets, and the units are in hundreds of units. So if the price is $2, how many movie tickets would you buy, according to this example?
100.
500, very good. So use the P times Q, so 2 times 500, you have 1,000. Got it? That's your total expenditure. Okay, the next thing happen is we're going to raise the price, double the price to $4. If it's $4, how many would you consume? Can you tell? You just draw the line here, right?
400.
Right, 4 times 400 is? 1,600. Very good. Is everybody with me? So what that means is when price goes up, your total expenditure goes up. Same direction. One's up, the other one is up. Okay? Next, we want to look at the case of elastic demand curve. Now, the reason that this is considered inelastic portion is because this is below that midpoint. Where's the midpoint here? Somebody tell me.
6.
Okay, the midpoint is at $6. Very good. And your quantity will be 300. So that would be 1,800. And because the reason for mentioning the midpoint is because everything below it is considered inelastic. So in the inelastic portion of the demand curve, when you raise the price, your total expenditure will go up. So now, of course, the next question is, would it be the same if you look at the elastic portion of the demand curve? So that's a question we ask next. What do you think? What's your hunch?
No.
Okay, no, very good. You were probably correct. Let's look at it. So next we look at this, right here. Okay, $8 is above that midpoint now, isn't it so? Okay, so at $8 you consume 200 units. So that would be 1,600, correct, everybody? With me? Okay, so, and it called elastic portion of the demand curve because now we're looking at the demand curve, portion of the demand curve that's above the midpoint. Got it? Okay. So this is very important because we ask you a question like that on your test. So there's a hint to you. So next we're gonna raise the price, and without showing you the diagram first, I'm gonna ask you, if I raise the price to 10, what will be the total expenditure?
1,000.
Sorry?
1,000.
1,000, very good. How do you know? Because you take 10 multiplied by 100. Very good. So sometime I want you to think before I give you the diagram. Because then you do a little bit better if you're thinking. So this will be 100, so now we have 8,000. So what's the conclusion here? If you're looking at the elastic portion of your demand curve, when price goes up, your total expenditure will end up
Go down.
coming down now. And see, they move in the opposite direction. And this move in the same direction. And that is a great hint to you. Because we'll ask you a question like that, we'll ask you in so many different ways. But if you know that concept, no matter how we ask you, you know the answer. So it is, this is a summary of the two diagrams you just saw. Okay, there are two diagrams here, and this is the one you just saw. But now we didn't have this total expenditure, we just put everything here, the quantities here, the price are here. So remember the midpoint is here, 6 times 300, you got 1,800. And then this other example you have. But look at the graph on the right-hand side. Would somebody tell me, what do we measure here in the y-axis of the graph, or the vertical axis?
Total expense.
We are measuring total expenditure, so be careful now. It is not the price anymore on this diagram. Over here, the price is the vertical, on the vertical axis here, the total expenditure. So you see a roller coaster shape or art, like this St. Louis art, you know. How many of you been up there? Nobody, okay. You know what I'm talking about? In St. Louis, there's a arc, you know, like famous one. You could go up there and view the, you know, the city view. So right here, this is the, what's on the x-axis? Somebody tell me. The what? The price, yes. So instead of on the vertical axis, the price now is at the bottom. Everybody see that? So then we go back to that. We say, okay, the total expenditure we already know. In this case, 2 times 5, 1,000. So if it is $2, total expenditure is 1,000. And if it is $4, total expenditure is 1,600. And then you reach the max, which is the top part of that inverted U shape, which is your midpoint, right? Which is $3 times, as I said earlier, $3 times 600. So then you got 1,800 there. And then after that, it comes down. Let's see if that's true, because see, $8 here. And so you got 1,600. So then it comes down again. And then further, $10, it comes down again, 1,000. Wow. So what does that tell you? That tells you that the midpoint is where you maximize your total expenditure. And actually, I should tell you one more thing. So if it is at midpoint, you would have, that would be your unit elastic, wouldn't it?
Yes.
Okay, because we talk about it, that's when your price elasticity here is exactly equals to 1, but below it is, see if you remember it. Inelastic, right, which means your number will be less than 1. And above it will be elastic, your price elasticity at the end will be greater than 1. This is very important, we're doing this slowly, because this concept, you could apply it. So on the test, you see the application. Because practice, the flash quizzes help a little bit. They're not gonna be identical to the question, but typically I tell my students that the flash quizzes tend to be more straightforward. If you could do your, flash quizzes, then the applied question will be more on the test. Sometimes they apply question on the flash quiz. I try to go back and change, give some example, but, as much as I could. Okay, so total revenue is at the maximum at the midpoint on a straight line demand curve. So then you know that. So somewhere in between here, right, at midpoint, I'm just gonna write that down. Your price elasticity will be equals to 1, and we call it unit elastic. So your total expenditure stays constant. It doesn't change. So be sure you write that down. Okay, next, so once you understand this concept, you could look at your book. Let's turn to that page, see if we could find it. That would be on page, everybody see this page where you have the arrows? Yours would be pink and red. Is that 121? Okay, page 121, thank you. So now we're gonna re-emphasize that point. We're gonna say it in more than one way so that you get it. So by seeing this, that's good, how we're telling you the same concept over and over, but in different ways. So when you see it on your test, you know we're talking about this concept here. For an elastic product, quantity demanded is highly responsive, percentage change in quantity dominates. So therefore, in this case, we say that input expenditure comes down. But when price dominates, which is the inelastic part, let's see, oh yeah, now we're talking about elastic. So the quantity will dominate, so if you increase the price, it will reduce total expenditure. So the main thing is that price and total expenditure move in the opposite direction. And that's the case of the second one. So don't get the two confused. So if you take notes like that, it's very clear, Go back there and say, okay, which one, yeah. So this move in the opposite direction, we're talking about that. That's when your quantity dominates, excuse me. Now, on the other hand, for inelastic product, that would be your case 1, quantity demanded is not so responsive. That's why we call it inelastic. I hit you, you didn't yell, you didn't shout, you didn't react. You're very inelastic. Or unresponsive, it's the term, or insensitivity, insensitive is the term, the synonymous term that we used the other day. So quantity demanded is not responsive, the percentage change in price dominates. And that's what the diagram showed, right? Okay, so therefore, if you increase the price, it will also increase the total expenditure. And now they move in the same direction, so that's what it means here. Right here. So you see, if you just read the PowerPoint slides, you wouldn't understand. If you don't come to class, you just look at PowerPoint slides, chances are you have to figure it out by yourself. But if you come to class as explained to you, then this makes a lot more sense now. And by the way, I also sent out this video link for the class lectures. So I hope some of you are watching it. It's not a substitute for class absence. But I would like some feedback. So if you have watched it, you want to give some feedback, please send me email so I can improve it. So the point is really to help students review their test, it's always available, but sometimes I forgot to send the link, and then semester will go by. So okay, that's what it is. And you already look at the page number 121, table 4.3. Where you see all these arrows coming down, going up. Again, one more time, here's the rule. When price elasticity is greater than 1, we call it elastic, and that's your case too. Changes in price, changes in total expenditure move in opposite direction. But we can ask you the question in such a fashion that you have to figure out this means elastic. Okay, so the second part, when price elasticity less than 1, changes in price, changes in total expenditure, move in the same direction, and you straight away know that's referring to case 1, which is the inelastic demand curve. So the next thing that I want to tell you is this part here. Has everybody had a chance to copy this? I'm gonna erase this. And what I'm gonna do is, I'm gonna write down this equation for you. So please write this down, because your book does not give you as explicit. So this is your income elasticity of demand now. So there's such a thing called income elasticity of demand. There's also such a thing called cost price elasticity of demand, where we have X and Y. And X and Y stands for goods, but let's talk about income first. Y stands for income. So in equation, this would look like this: percentage change in income. How would that affect your percentage change in quantity demand? Okay, so the only thing that changed was before you have a pricing. So now, instead of price, we say if your income goes up, you would take more Bahamas vacation, or you would buy a sports car, for example. So if that's the case, right, this are considered, we studied that before, normal good. If your income goes up, you consume more of it, that's your normal good. But if your income goes up, you consume less of it, that will be your ramen noodle. You buy less of it, you consume less of it. So then it's negative. So negative means if this goes up by 10%, then your consumption goes up by more than 10%. So then we call this a normal good. Okay, so all you need to know here is the sign, whether it's positive or negative. If it is positive, means it's greater than 0, you're referring to normal good. Vice versa for inferior good. So next one is price elasticity, but instead of saying price elasticity, we call it price elasticity of demand. And we have touched on this concept in chapter 3 without you realizing it. Remember we talked about substitute? Remember we talked about complements? Anybody remember that? Okay, in the cost price elasticity of demand, you also have two situations. I'm going to write it down for you. The definition is percentage change in price of X will lead to what kind of percentage change in quantity demanded for Y? So again, in the case of substitutes, we say that this will be greater than 0. And this is a case of, let's give an example. And if it's less than 0, we say this is complementary with an E. Just like the example we had before, remember the tennis ball versus the court renting fee? So let's look at the substitute. Okay, so if the price of X goes up, and X is Coke, for example, okay, then you buy less of Coke, you consume less amount of Coke. So what about Pepsi? You will buy more Pepsi, because if it is more expensive with your Coke being a substitute, then you buy less Coke, you consume more Y. So that would be your Pepsi as an example. So they move in the same direction. So therefore, this is your substitute. Same direction means if one's up, the other one is up, so it's a positive relationship. They move, they have the same relationship, be directly related. That's another term you could see, positively related. Now, if it is less than 0, we call it complementary. So example we give would be like price of, remember we gave the example of milk and cereal? Most of you eat cereal with milk, correct? So if let's say price of milk goes up, you consume less milk. And as a result of that, some of you might consume less. So what? So your Y is your cereal, milk is your X. Okay, so because now they move in the opposite direction, so you get a negative relationship between price of one good versus the quantity demanded of the other good, of which it is a substitute of, or the complement of. So that's what it is, opposite